Can you find this missing side without using sine, cosine, or any trigonometry? We have a right triangle, ABC. The right angle is at B. Angle C is 36 degrees, and the hypotenuse, AC, has length 2. Our goal is to find the base, BC. Let's call it X. But there's a catch. We're not going to use trigonometry. No sine, no cosine, just pure geometry. So we need a clever construction. Here's the trick. Extend the bottom side, BC, to the left, past point B, and mark a new point, P. Now connect A to P, so that triangle ABP is a mirror image of triangle ABC. Because the two triangles are mirror images, their corresponding side lengths and angles are equal. Since AC is 2, AP is also 2. Since BC is X, BP is also X. And because angle ACB is 36 degrees, angle APB is also 36 degrees. Now comes the next construction. Extend the line PA beyond A to a new point Q. Then connect C to Q. Choose Q so that angle ACQ is 36 degrees. Now let's look at the large triangle, PCQ. At point P, the angle is 36 degrees. At point C, we have two adjacent angles, each measuring 36 degrees. So the entire angle PCQ is 36 plus 36, which is 72 degrees. And since the angles of a triangle add up to 180 degrees, the angle at Q must also be 72 degrees. So triangle PCQ has angles 36, 72, and 72 degrees. That makes it isosceles. The sides opposite the two 72-degree angles are equal. So PC equals PQ. Now let's call the small segment AQ lowercase a. Since PA is 2, the entire segment PQ is 2 plus lowercase a. And because PC equals PQ, PC is also 2 plus lowercase a. Now let's look at the smaller triangle, ACQ. We already know that angle ACQ is 36 degrees and angle AQC is 72 degrees. So the remaining angle, CAQ, must also be 72 degrees. That makes triangle ACQ isosceles too. Since AC is 2, CQ must also be 2. And now we have the key idea. Triangle PCQ and triangle ACQ have the same 3 angles. So they are similar. Therefore, their corresponding sides are proportional. We can write 2 plus lowercase a divided by 2 equals 2 divided by lowercase a. Now cross multiply. Lowercase a multiplied by the quantity 2 plus lowercase a equals 4. Expanding gives us a squared plus 2a equals 4. Now let's complete the square. Add 1 to both sides, and we get a squared plus 2a plus 1 equals 5. The left side is a perfect square, so the quantity a plus 1 squared equals 5. Taking the positive square root, a plus 1 equals the square root of 5. Since a is a length, we take the positive value. Therefore, a equals the square root of 5 minus 1. Now go back to PC. We found that PC equals 2 plus a. Substituting our value of a, PC equals 2 plus the square root of 5 minus 1. So PC equals the square root of 5 plus 1. But there's another way to write PC. The segment PC consists of PB plus BC. Both of those lengths are x, so PC equals 2x. Therefore, 2x equals the square root of 5 plus 1. Divide both sides by 2, and we finally get x equals the square root of 5 plus 1, all divided by 2. And that is our exact answer. And yes, that's exactly the golden ratio. Pretty amazing. A simple 36-degree triangle with no trigonometry at all leads us straight to one of the most famous numbers in mathematics. And that's what makes this construction so satisfying.